Not yet, guys. You've got 25 minutes of this. So just a preliminary note. I don't feel it's rude for you to use your laptops and phones and stay connected during the talk. There's the hashtag. We can embrace the back channel. You don't have to keep concentrating. And those of you who know how to make a post request, you may want to have your laptop or with curl or postman ready, because there's a bit of an interactive component to the talk just coming later. So I call this talk APIs for Cyborgs because I consider myself a cyborg. I have a glass-coated NFC transponder implanted in my left hand, and in a few months I'm going to attempt to insert magnets into my fingers with a scalpel. So one of the most common questions I get asked after why is how. The chip itself is about 12 millimeters long and 2 millimeters wide. And when I ordered it from the Dangerous Things website, it came in a sterile packet like this, loaded into a 10-gauge syringe assembly. So I'm going to spare you the details, but here's a basic diagram of the procedure. I'm not unique in this. The biohacking community is growing. Some of you in the audience may also be biohackers or grinders. Do we have any other DIY cyborgs here? No? Okay, that's cool. I mean, DIY cyborgs aren't the only type of cyborgs. You might consider yourself a cyborg if you've got a pacemaker or an IUD or a contraceptive implant or obviously a bionic limb. I mean, prosthetics have been around for millennia, but wireless networking hasn't. So through the internet, cyborgs are starting to realize their potential. So let's go into what actually is a cyborg. My definition has two parts, and I'm going to give you the first part now and the second part later. Here's the first part. A cyborg is someone who has augmented their body's capabilities through permanent, non-human hardware. So as long as we have an idea of what a machine is, we have an idea of what a cyborg is. A human fused with a machine, a kind of Maschinenmensch. It wasn't a big decision in my life to become a cyborg, and I think that says more about the present than about me. So you're probably all used to the idea that everything has an API these days. We've been hearing about APIs in this room all day, and I'm actually in contact with a company called Mystery Vibe, which makes a vibrator with a REST API, which I think is awesome and probably going to be a lot of fun to reverse engineer. Okay, so here's the thought that got me started on this talk. What if there were an API for the human body? So this talk is just my preliminary research into the area, and I'm here to get inspiration and ideas from all of you and understand what more could be done and what other awesome demos we could have next year. So before we jump into some live coding, I'll give you a quick crash course in near-field communication, which is the technology that I've got implanted. So, NFC. Sorry. It's radio communication at 13.56 megahertz, so it's just radio waves. It's got a 1 centimeter to 4 centimeter range. It's a pretty small range, so I don't have to be worried about people across the room scanning my hand, although there is no theoretical limit on how big you could make an NFC antenna, I guess, though I don't think I've ever seen a massive one in the wild. The tag I have in my hand is a passive tag, as opposed to an NFC reader or emulator. It draws its power from the electromagnetic field generated by the reader. So there's no battery in the hand, there's no power source that's going to run out. All it is this loop antenna, which is going to be conducting the electromagnetic field that is made by the reader. Each tag, depending on the manufacturer, will usually have a hard-coded unique ID. This can't be changed, and it's usually digitally signed, so you know that the manufacturer guarantees that the ID is unique. I mean, it's probably possible in most cases to clone the tag and bypass that kind of thing. So I'm going to talk a bit about the security later. But for the moment, we can assume that the ID of the tag is unique. It's got a unique ID. It contains data, structured data, 888 bytes maximum, structured in what's called NDEF records. This is just a basic data structure where you've got things like well-known records where you can encode a URL or text or even sort of multimedia, vCards, stuff like that. So before we jump into the live coding, I'm just going to show you what exactly I'm going to do with it, with the hardware. So this is a PN532. I got it from Adafruit, and it's basically got this antenna and a load of things that I can use to connect it to my computer. So what I'll be using today is an FTDI cable, which allows me to have serial to USB communication. This kind of feels like cheating, because usually you have to plug this kind of thing into an Arduino. But since I wanted to write JavaScript on this, and more of that later, I wanted something that I could just plug into my computer and not have to have any intermediate hardware. Okay, so naturally, as soon as I'd implanted this uniquely identifying thing into my body, I thought, let's connect it to the internet. To fulfill my dream of being globally addressable. But I mean, there's also a performance art piece that I can't really talk about on stage, but ask me about that afterwards, please. Okay, so I chose to use JavaScript for this demo, as it's massively popular. You don't have to wait for it to compile, and it's super simple. So yeah, so here's my stack. It's really super simple. Yeah, really simple. I mean, I made some of these up. Okay, right, great. Let's do this. Let's get to the code. Okay. Great. That didn't work. Okay, so we're going to use a couple of helper libraries here. As usual in JavaScript, everything is quite modular. So the first thing we want to do is to be able to actually communicate with the serial port. So if I go into my terminal and lsdev, which I'm not going to do because it'll probably mess up the presentation, I'll be able to see a new device there, which is this, which we're going to see on the Elmo in a moment. And that has this unique address that I've just hard-coded here for ease of use. So by the way, please feel free to shout out if you see any mistakes. I like to think of this less as live coding and more as sort of high-stakes pair programming. Right, so what else do we need? We need, right, so I mentioned before that the records on the chip are organized in an NDEF format, and thankfully someone's written a very helpful node module for me to format those records, so let's just require it. The last thing we need to do is install a driver for the PN532 itself. So if you recall, this is the NFC antenna module that I've got connected through my USB FTDI cable. So we're just going to get the constructor here. Awesome. So these things can sometimes be a bit flaky, and I'm really relishing the idea that this is not going to work, but let's have a go at actually connecting to this thing. This step in preparing the live coding took me about a week, because the amount of drivers interfacing with libnfc, all sorts of crazy stuff you have to do to get this to work. But so these few lines represent quite a lot of work here. Okay, so let's get the serial port. Okay, so notice there's a baud rate here. So any of you familiar with Arduino programming will know that when you're going over serial, you need to define the baud rate. As far as I'm concerned, this is just a static thing. There's no reason that would ever change. The great thing about the PN532 library is that we can just wrap the serial port like this, and everything should just work. So let's just check if it's ready first. So we're not doing anything with the tag yet. We're just going to see if the board has initialized properly. So let's run this. Great, PN532 ready. You can't see that, can you? There we go. That's what I want to see. Yes. Okay. Right, so I've got a couple of tags here in my box, which I'd like you guys to come and collect afterwards, because I've put some fun stuff on them. So here's one of them. I'm going to try scanning this. So I'm going to show you the kind of raw data as it comes back from the tag, as raw as you can get in JavaScript. Okay, so in fact, why don't we switch to the Elmo for a moment so I can show you just what it looks like scanning a tag. Great, so here's the board. Here's my tag. The tag itself is a little sticker that I've stuck onto a card. You see, it's very thin. It's lucky that it's very thin, otherwise I would have had a far more painful procedure getting it into my hand. Great, and it's scanned. Okay, so let's switch back from the Elmo now. Thanks, Brandon. Great, so what we've got is some data now in our console. So this kind of looks like a load of nonsense, but that's because we're trying to log buffer data to the console. The interesting thing, however, is that we've got a UID here. So if we take note of this UID, the important bit is that the second block is 6C. Then we scan a different tag, we'll notice that it's got a different UID. So let's just log the UID. It's probably easier. Great, so I've logged the UID of that tag. Now let's log the ID of my hand. Great. That was pretty quick. It's a lot quicker than doing this than when you scan it on an Android phone, unfortunately. The first guy I met with one of these implanted in his hand had his business card on there, which was awesome. However, you had to hold your phone over his hand for at least a couple of seconds, during which time you could have just given a business card or something. So that was not the most impressive demo of the tech, but these things are really fast because they port really quickly. Great, so we've got the UID of the tag, but I mentioned it can store a load of data, 888 bytes of data. So we're going to use the NDEF library to read this data now. The NFC library that I'm using, the PN532 library, sort of has a mixture of promises and callbacks. See if I can remember which one is which. So I'm going to read the NDEF data. So let's just log the data first. We're going to log the data on the card, which I put somewhere. Okay. Great. It's a lovely buffer. I hope that means something. I'm not sure what exactly I put on that card. Let's try this one. Let's just switch to the Elmo for a moment because I want to show you the read range of this thing. So I'll tell you when it's reading. Okay, it's reading now. So that's about sort of 2 centimeters away from my hand. So you don't have to tap it. The uses of NFC are various. In London, we have something called an Oyster card. I don't know if you have similar things like public transport and stuff here, but you scan your you scan your NFC card on the reader, and you can pay for your travel. Can we switch back from the Elmo? Thanks. So most people have to touch the card on the reader, and there's probably a bit more data transfer going on there than here. But in theory, you don't even have to touch your card on the reader. You can just wave it around. Great, so we've got some buffer data. This data is formatted according to the NDEF specification. So using the NDEF library, we should be able to read the data. So let's do that. So what I'm going to type next is not particularly interesting because it's just the format that we have to do this in. So we want to decode the message. Slight hack. Okay, so when we do this, we should be able to see the actual data that are written onto the card. So if we're lucky, this will be in a human-readable format. Fantastic! Yay! So that was just the card here. I'll show you the rest of this. So NDEF records, as I mentioned, come in several types, and you can see what the library here has done is parse the types into these one-letter symbols. So U is URI, and T is a text record. There are all sorts of other kinds of records that we probably won't go into today. So the first one is just a URL record, Twilio.com. So what this actually means is that if you tap your Android phone on the card, then it'll immediately come up with that URL in the browser. I was quite surprised when I discovered this because it feels somewhat like an invasion of your privacy when you touch your phone on something, albeit accidentally maybe, and a URL comes up, perhaps with some sort of auto-playing video. So I thought, this is great because I can invade people's privacy just by touching my hand on their phone. Like I can make it do all sorts of things. So let's see what I put on my hand. I can't actually remember. Sorry. Ah, hello. Great. That was creative. And we've also got the Signal website, so in case we forget, just come and tap your phone on my hand and you can get straight to the Twilio website super quickly. Okay. Right, so that's reading the card. We're next going to write to the card and the hand, which is much more interesting. So just open the file. Okay, so there's a bit of stuff I made earlier here. We're requiring all the same libraries, except that we've got request as well, which is a very common Node.js library. I don't know how many of you are JavaScript programmers, but request is what you use if you just want to make a really basic HTTP request. So let's do the same thing as we did before. We want to initialize the device. So we want the serial port. And we want to wrap it in the NFC. Oops. So we're going to do just the same thing as we did before. So I've just put a callback in here. Great. Let's try running that. It's not going to work because we didn't stop the other process. Great, the PN532 is ready. Okay, so instead of reading this time, we're going to write to the tag. I think it's probably slightly more involved than last time, so I'm going to try to keep scrolling up. Let me know if you can't see it. So what we want to do is get some data, format it according to the NDEF specification, and then write it to the tag. And later, we'll probably get some more interesting data and write it to the tag. But for the moment, let's just say our data to write is hello signal. So we're also going to write a URL to here, just so I can show you how that works. The NDEF library comes with some very useful things like URI record. Yes, great. arbitrary URL. And let's put our data to write there. Great, so now we've got the messages. We can write them using the ndef library to the card. So let's use the PN532's useful function, which is write ndef data, awesome. So the reason we have to format it into an ndef format is that if we didn't have these sort of shared protocols, then there would be no way to understand which format the data was in, and so it wouldn't be possible to understand any of the buffer data you got. I mean, you could get the buffer data, but it wouldn't really mean anything. So yeah, let's encode it. Oops. Oops, encode message. Okay, so what we should be able to do now is let's do this kind of standard JavaScript thing of assuming that everything went fine and not wait for the response and just say.
Are you supposed to pass data or messages?
Thank you very much. See, pair programming, this is awesome. That would have been bad. Okay. And well, I haven't yet bricked my hand, but it's probably possible to send it something that it doesn't like. Although, I mean, there's no microprocessor in there. Oh, write successful, that was surprising. Is there some sort of NFC tag on the table? Okay. Interesting. So what we've done here is we've said as soon as the NFC board is ready, we're going to write the data. Unfortunately, what I forgot to do was wait for the tag to appear. So let's wrap everything in that. So this is a really sort of simple API. The fact that it's mixed callbacks and promises makes it a little bit more challenging, but let's just stick that in there. Okay, cool. So this time, it's going to wait for a tag. Great, right, successful. Okay, so let's go to the read script and just quickly check whether that worked. Great, so now we've got a payload of hello signal on our tag. That's not the point of this talk, though. The point is to write it to my hand. Let's do that instead.
Question for you.
Yeah, sure.
I'm not seeing any security here. What's to stop somebody from rewriting your hand on the subject?
NFC security is an interesting problem, actually. I'm really glad you asked that, because I was going to talk about it later. So what the NFC spec actually says is you can lock certain bits of the tag using, I think it's a 32-bit sort of passcode. I've done this, and it's possible to get around it. Okay, this has taken a lot longer than I thought it would. Great. Okay, so let's. Oh, sorry. Okay, so let's just write some data to my hand, blast through the end of the talk. Okay. Right. I'm afraid we're not going to have the interactive component today, but maybe tomorrow morning we can have a little session where we do that. So, great, right, successful. Okay, there's now some data encoded on my hand, and you can tap your Android phone on it or similar. Okay, cool. Let's. Okay. Great. Okay, so I made another demo, which I'm really glad I didn't do, because I really would have run out of time then. So two-factor authentication, let's go through this really quickly. The basics of two-factor authentication are to ask the user to provide something they know and something they have. In this case, something they have is something they have inside their hand. So what we can do is we can say the client will make the request to the verify endpoint. I'll scan my tag, and it'll receive a reply. So you can actually kill this endpoint, but it's not going to work at the moment because I don't have the client code running on my machine. There's a web sequence diagram. I mean, I think we can completely skip this just because, I mean, you've probably seen enough of these already today. There's I don't know, there's nothing worse than other people's web sequence diagrams. It's like other people's dreams. Okay, so I'm going to conclude with some thoughts on further lines of research and what I think all of this really means. The limitation of this demo, you may have noticed on the slide before, was that there's only one user who can use my two-factor authentication flow and only one user who can use all this. I think it's interesting how a lot of IoT demos are very individualistic. They're not about connecting necessarily with other people. They're about automating your own life. This isn't something I've really explored that much, so it's kind of area for further research. Something I think is more interesting, which comes up with the security point you made, was that it's really hard to be anonymous when you've got something that's uniquely identifying inside your hand. And I have to ask myself why. Why do I want to become assimilated into the Internet of Things, and why do I want to expose my own body in a globally addressable space? Whoops. And what if there's a showdown search engine for people's bodies? At the very beginning of my talk, I mentioned that the definition of cyborg has two parts. So a cyborg is someone who's augmented their body's capabilities through non-human hardware. But I think naturally the control sort of flows the other way as well. Having this hardware in my body has changed my behavior. I'm not sure whether someone who scans their phone on my hand is going to try to brick the chip, is going to try to lock it or wipe it, or do any other sorts of things that you can do just by sending certain data down the wire, well, over the air. Embodied data is something I think is really interesting. So I was at the Tate Modern on Saturday, and I met this artist who explores what it would be like to become a book. She consumes books, and she wears books, and she explores the potential of embodied knowledge. And this was, of course, super interesting and relevant to me. I mean, you may say, well, you already embody knowledge, you can remember information, but the way the brain works isn't just as a store of data, it's more of a sort of process. It's not really persistently stored, and I can't have the same thought twice. The information is encoded in my DNA, for example, but I can't access it. But when I have it statically stored on a passive medium in my hand that requires no power, I'm really embodying data. Sorry that ran over a bit, and thank you very much.